that I like to write vertical shift at what? The plus 3 tells me that my what is at 3? The oscillation line. So when I write vertical shift at 3, I know that my oscillation line will be at 3. And folks, when I finally wrapped my head around the fact that these curves are their foundation is the oscillation line, then it became so easy for me. But until I did that, this was not easy. Okay? Yes, ma'am.
Okay. So if it's the negative before the sign is reflect, and then if it's a positive,
it does not reflect. It's the normal curve. Always. Okay? All right, so let's graph. Here we go. Okay? We're not worried about period right now. Don't worry about the period. We're going to get to it. We're taking baby steps. We're going to get back to it at the end. Oscillation line is at 3. So 1, 2, 3. This is where I like to use a highlighter. And if you look in some of you guys come in here before school starts in the mornings, and you will check my homework just to make sure you're on the right track. Okay? Come on now. There we go. And you'll notice in my own homework that I've highlighted my oscillation line. But it's at 3. I know that my amplitude is 1. That means over here, folks, if this is at 3, then the curve is going to go no higher than what number? 4 or no lower than 2. Is it important that I put those values on my y-axis? Yes, it's very important. You can't just let that go. Now, where does my sine curve start? Does it start on the oscillation line or above or below it? It starts on it. And it starts on it at 3. Where are you? There you are. And is it going to go down or up? It's going to go down first because it's reflecting, and that's what my little list tells me, shows me. So I'm going to go down, bless you, up, and then back down. It starts and ends on the oscillation line. Are y'all cool with that? Yeah? Yes, ma'am.
You know how you did like the little curvy line up? Can you go up for some like? What does that mean? The little curve.
This one right here?
Yeah.
This one means yes because it's a negative.
Yeah.
This one?
Yeah.
Because it's showing me that when I draw my curve, it has to go down first.
Oh, okay.
No. Right, I got you. No, I will draw a cup. Or either I'll write up cup, down cup. Okay? All right, here we go. Did my minimum value go to 2? Yes. Did my maximum value go to 4? Yes. Everybody cool? Is this easy so far? Yeah, it is very simple. Don't make this more difficult than it needs to be. No, not necessarily. I use them. What do I do them for? They serve as guides for me. So I'll know how high to go, how low to go, and just make sure my curve goes through them. Sometimes my curve does go through them. Sometimes it doesn't. When we get there, you'll know. Okay? Here's another one. Now let's look at number 3 from the worksheet. -2 plus sine of x. What is wrong with that? It's in the wrong order, so ding, 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 what do I need to do? I got to move this thing around. I've got to put it in the correct order. So I'm going to take sine of x minus 2. You guys cool with that? I've got to make it look like my original formula, my original given equation. So I'm going to take that minus 2 and I'm going to throw it to the tail end. Does it always have to be thrown to the back end? Yep, it sure does. If it doesn't, then you're going to think, ooh, that's something different. And that is not. That minus 2 means because it is being added to the sine of x or subtracted, it means that it's causing that vertical shift of my curve. Okay, so here we go with the same thing we always do. Okay.
Okay, so if it does reflect, it always does the curve little thing.
Well, look at the sign, the SIGN sign of sine. Is it positive or negative?
Yeah, I know that one doesn't reflect, but I mean it does. No, it doesn't. It doesn't reflect. But I'm talking about the one before that. If it does reflect, it's always a curve to the right, like down.
It's always going to go down first.
I know, but why did we go right?
Because it's positive. And we have not shifted it horizontally yet. You don't know how to do that yet. Okay? Everything's going to be to the right of the y-axis thus far. Okay? Good question. We just haven't shifted anything. Okay? We're going to, but not yet. All right, here we go. No reflection. Sine curve, is it going to curve up or down? It's going to go up, so I'm just going to draw my little up. Then my amplitude. Folks, what's the amplitude? It's the absolute value of 1, which is 1. And then vertical shift at -2. Is everybody cool with that? Yeah? Folks, I don't want you to come in here tomorrow and go, I didn't know. I don't understand. And you sit here and not ask any questions. Okay? That's not cool. That's not cool for me. That's not cool for you. And it's not cool for your classmates. So ask. Here we go. Vertical shift at -2. First thing I have to draw is what? Oscillation line at -2. There it is. It's going to have an amplitude of 1, so it's going to be 1 above and 1 below. So we've got -1, -2, -3. Are y'all cool with that? Yep. There is no reflection. How high is this curve going to, what's the maximum value of this curve? It will reach -1 and it will go down to -3. So since it's going to go up, I'm going to put here and then here. And I'm just using those as guides. Just using them as guides. Watch what I do. I'm going to go up and then back down. Bless you. Are you with me, yes or no? Everybody cool? Facile, difficile? How many of you say, I see, I see? It's all right? It's all right. All right? Questions at all? Maybe this will go. Okay, let's talk about period. Throw it in here at the end. What does period talk about? The period is the length of our curve. Up until this point, we've been dealing with the unit circle, and we've been dealing with revolutions, right? That's what we've been dealing with. Okay? It's like taking a piece of yarn and kind of placing it all around the unit circle, and now we're going to cut it because we've put it all the way around, one revolution, and now we cut it and we're able to take it and kind of fling it like, all right, there's a sine curve. Oh, there's the cosine. Think about a rope. Can't you make a rope, or if you were to really look, or we were to film you taking one end of a rope and going like this, which curves are you making? The sine curves. That's when you take that rope. You remember, y'all have done that. Everybody's done that. When you do that, you're making the sine curve, okay? Think of that piece of yarn. It's now one revolution. One revolution on the unit circle is how many radians? 2 pi. 2 pi is important to us. So if I had to put the period, remember the period is going to be, one revolution is 2 pi, but the period to determine the period of our curves, it's 2 pi over b. you better put a box around it, stars, ponies, and unicorns. It's very important that you understand it's 2 pi over b. B comes from the coefficient directly in front of x. You need to draw an arrow so you know exactly where it comes from. Okay? Now, if this is 1 revolution and I had to label, folks, this is where it gets kind of, this is easy. 1 revolution is 2 pi, right? So, please label your x-axis and not your oscillation line. So many people do that, and that's just me with pet peeves. Don't do that. But halfway, what's halfway to 2 pi? Think about your unit circle. Pi. What's half a pi? Pi over 2. And if you don't get it, if you don't understand that, write it out. Half of pi. Mathematically, what does of mean? Multiplication. 1/2 times pi over 1. When you multiply that, what do you get? Pi over 2. If your brain is not functioning at 100% one day, and you just kind of are going, what? Then if I wanted to determine 1/2 of anything, whatever that thing is, then you better take 1/2 times that value. It's not going to always be easy, because you better get in touch with your fractions. And you're going to think back to the unit circle. For here, it's easy. Check this out. What's 1/2? 2 halves. What's the next spot? 3 halves. And then isn't 4 halves 2 pi? It's the same thing we did with the unit circle. Remember when we went through pi over 3, 2 pi over 3, 3 pi over, remember doing that? Or the 6, we did the 6s. 1 6, 2 6, 3 6. And then they all reduced and simplified. So we're going to do the same thing. Let's take another look at another one. Or take a look at another one. Let's go to the cosine. Because a cosine curve is when we think what? Up cup, down cup. Okay? Up cup, down cup. I just looked at it, Christian, and I said 1/2, 2 halves, 3 halves, 4 halves. Just like if when we ran around and you were putting in all those increments on the unit circle. Remember how I showed you to do that? You just think in terms of fractions. 1/2, 2 halves, 3 halves, 4 halves. And then reduce when you need to. Okay? That's all I did.
When do you know when to do just like the half and the eighths and those ones?
We're getting there. We're getting there. And you'll be like, got this. Okay? All right, here we go. Cosine is the cup. Up cup, down cup. Let's look at number, still on that worksheet, number 5. We're going to start very basic. Cosine x minus 1. Okay? Doing the same thing we've been doing. This time we're going to add in the period. Okay? So, reflect. Does this cup reflect? No. So is it an up cup or a down cup? It's an up cup. Draw it so you'll know what to draw. Reflect. Amplitude. Well, what number's in front of cosine? 1. So it's the absolute value of 1, which is 1. Which means it's going to be 1 unit above and below the what? Oscillation line. Let's keep moving across our equation. Our coefficient in front of x gives us the period. Remember, your period is 2 pi over that number. Let me get the blue. What is that number? 1, which means the length of our curve is 2 pi. Do you guys agree? That's all right. We're looking here at the coefficient in front of that x, and we know that it's 1. Do you agree?
Yeah.
I know that my period is 2 pi over that coefficient. So it's 2 pi over 1, which is 2 pi. Okay? And then, oh, right here. What is it? Vertical shift at who? At -1. Do I have enough information now to draw my curve? Yes. Oh, let me tell you this. I told first block. I expect every person in every 3 periods that I have to do all of this. I'm telling you, if you do this, you will not make careless mistakes. No one is exempt from showing that work. Do you hear me? No one is exempt from graphing these curves without showing that information. You don't show it. Now, this is the one time that I'm going to be a real about that. Some of you guys never show any work because you do it all in your head or on your calculator. That's cool. It's going to bite you at some point, and I don't want it to be. Please start showing your work. But for this right here, I expect you to show this. And I don't typically take off points, but if you don't show that information, I'm going to blow you up. Okay? Here we go. Let's go with it. Okay? I think it's it. All right. They did not? Okay. Here we go. So, what's the thing that I have to draw first? Oscillation line. Here we go. Oscillation line is at -1. There it is. So I've got -1, -2, 0. Do I need to go any higher, any lower than that? Nope, I sure don't, and I hope you know why. Here we go. Reflect. Where is my curve going to start? At 1 above. It's going to start and end at that 1 above value, won't it? Okay? It's an up cup, so I'm going to go 1 below for my minimum value. And folks, it needs to be smooth and beautiful. Do not draw a parabola. I'm going to count points off if you do. And don't tell me, I can't draw a curve. Yes, you can. You better practice. You better figure out how to draw a curve and not a parabola. Okay? Now, for now. For now. Because we haven't added in phase shift yet. That's a good question. Okay? Any other questions on this? How many of you are still like, all right, I got this? Yes, sir. Notes. Because it can be confusing. The negative sine curve, Tiffany, is down, up, down. Okay? The cosine curve, the positive cosine curve is the cup. The negative cosine curve is the down cup.
Did you mean to put the green mark there?
It was already there. I just wrote over it. There you go. Okay? That's a good, I'm glad you asked. All right, so let's look at, I'm glad you asked that question. Let's look at putting those increments on your x-axis. It's going to run 0 to how far? 2 pi. Remember, you're labeling your x-axis and not your oscillation line. Sometimes it's the same if there's no vertical shift. That midway point, which in this case is our minimum point of our curve, what's halfway to 2 pi? 1 pi, or just pi. What is halfway to pi? 1/2 of 1 is pi over 2. 1/2 of 1 pi. 1/2 times 1 pi. Multiply straight across, okay? And then that's when you're thinking, Christian, what you were asking a while ago, 1/2, 2/2, 3/2, 4/2, which reduces, simplifies to 2 pi. Right on? Got to get into a habit of putting those increments in there. Here we go. Any other questions? Here we go. Here's another one. I want you to do this one yourself. This is number 1 from the worksheet. Don't look back. I'm just telling you that for a reference point. -2 minus cosine x. First of all, ding, 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 ding. What's wrong with that? Out of order. So how am I going to put it in order? How? Negative cosine x minus 2. Rock on. Do this one yourself real quick. Is this going to reflect, yes or no? Yes. That means it's cosine, up cup, down cup. Down cup. All right, reflect. Amplitude. What's my amplitude? Absolute value of -1 is 1 above, 1 below the oscillation line. All right, next we come right here. That coefficient directly in front of the x helps me find the what? The period. So it's going to be 2 pi divided by who? Which is 2 pi. Period represents the what? Length of the curve. Thank you. And then vertical shift at who? -2. All right. Everybody, how many of you had that hands up? Rock on, high five. Here we go. Oscillation line at -2. Here's -2, -1. How high? 1 above, 1 below. We got -1, -3, -2. Now what? Where does this cosine curve, this cup, start? Listen at y'all. It's going to start and end at -3, won't it? Means our maximum value will be no higher than. I'm so proud. Seriously. I could squeeze all of you. How about that? In a motherly way, not in a weird way. Like, yes. Huh? What? Question. Shh. One more time. That is correct. Because that normal cosine curve is a cup. Sine goes up. Up and then back down. Okay? And that's why I wrote it on that last slide. It's for you to, you got to lock in and put, border around it, and you got to lock into it. Questions on this? How many of you had this? Have I done? Nope. Now I got to label my x-axis. Dang it. What's it going from? 0 to who? 2 pi. What's my halfway point? Rock on. What's my quarter point? And my 3/4 point? 3 pi over 2. How many of you had that? All right. Yes, high five. Yes. All right. Questions at all? All right, let's look at that general equation then. The general equation for these functions are A sine Vx plus C plus D. So far, all we know about is A, which is amplitude, which is, how would we describe amplitude? You tell me how you would describe it. Seriously? You would describe it that way. That's correct. However, in relation to the picture, how do we use the amplitude? It's how many units what? Up or down with relation to the oscillation line. So, how many units up or down from the oscillation line. We can abbreviate anything, can't we? I know. Now, what was the next piece of the puzzle that it was important to us so far? B. B is the what? The period, which is always the length of the curve, and it's always 2 pi over b, isn't it? Guys, do y'all realize that's just a portion of the revolution? It shows you how many times it's revoluting or not revoluting. Is that a real word? Y'all are thinking about it. I see some of you going, That would be revolvulation. I don't know. I just made that up. But it is a portion of the revolution. Okay. What was the next piece that was important to us? D, which created the what? Vertical shift. And it helps us to know where our oscillation line is going to occur, doesn't it? Where our oscillation occurs. Oscillation line occurs. Right on? So, what's going to happen if our period isn't 2 pi? What then? We got to do a little mathematical calculations. Okay? So here we go. What if you had when bless you. When the period changes from 2 pi. If you were to have this equation, folks, y equals, bless you, sine of 2x. And I know we've been going through the reflex, amplitude, period. I know we've been going through that, but I just want to focus on period right now. The period is 2 pi divided by who in this case? 2. Which, when we reduce it, becomes what? Pi. This helps us label our x-axis, yes? Everybody with me so far? Yeah? Because some of you are going to be like, what? And it all goes back to fractions. But if the period of this we're not going to graph this, we're just going to label the x-axis. It would start at 0, and it would run to who? To pi, right? The halfway point. What's halfway to pi? Pi over 2. Now, if you are in touch with fractions, this is not a problem for you. But if you really struggle with fractions, this is not so easy, okay? What's half of a half? Pi over 4. Now, if I didn't know how to figure that out, if I didn't know that, how would I figure it out? I want to think half of what? Pi over 2, right? Of means what in math? Multiply, which is 1/2 times 1 pi over 2. Y'all with me? Now what? Multiply. 1 times 1 pi is pi. 2 times 2 is 4. And then you start thinking, stepping this thing off. Watch. 1/4, 2/4. What's this have to be? 3/4, 3 pi over 4. Because pi is just 4/4, isn't it? I'm telling you, this is exactly what I do every single time. It's not going to be so easy every time. What's going to happen when you have a fraction? What's going to happen when you have this jacked up 3? What if it happens to be a 3? What are you going to do then? Okay, let's look at another one. At some point in those notes, I want you to graph this yourself right now. Okay, don't look back in those notes that you tried to do on whatever day last week. Try this from scratch, okay? Okay, Easter, go. Stop talking. Shh. Shh. Right. Okay, Easter. Go ahead. Talk to us. Oh, wait a minute there, Easter. Okay, better. I was about to have a coronary. I'd hate to take points off for a correct picture. No reflection. Which means 3 above, 3 below what? Oscillation line. Go ahead. Ah, no vertical shift. So that oscillation line is the x-axis. This is a case where that happens. Go ahead. Sorry. Right on. Smooth and beautiful. All right. Okay, time out. And I'm not hating, but I'm glad you did that. Do you see how he just kind of went boom, 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 and put those marks in there? Okay, I want you to be particular about this. Am I being nitpicky? Yes, because I can be. When you get to be the teacher, you can be nitpicky too. But I would be more careful here. That's where I would put the middle, because the midway point is where our curve, where our sine curve crosses that x-axis. Okay? Say it again. No, not always. And the next one you'll see it's not going to happen. Now, look at his quarter-way point and his three-quarter point. Look at it. The fourth away there happens to be this curve's what value? Highest, or, give me a better word, maximum value. And the three-quarter point happens to be the minimum value. Right? Did he get all of his values correct? Pi over 2, pi, 3 pi over 2, 2 pi. How many of you look like this? Your paper looks like this. That's what I just said. How do you know? How do you know? Say it a different way. Shut up. Here we go. Thank you, Easter. Very good. The halfway point is where this curve crosses the x-axis, always, for the sine curve. Please stop talking. Your fourth point, which is here, half of the half, is this curve's maximum value. The three-quarter point has to be this curve's minimum value. No, because some of you, let's face it, some of you are going to draw a curve like this. And it is going to look crazy. Cindy. It is. It's going to look messed up. But I don't care if you got a messed up curve. I don't care if your hand does this when you try to draw it. I just want you to do this. 2 pi. Pi. Right? Pi over 2. And this messed up little piece is 3 pi over 2. It's all right. Because let's face it, who can draw a small, smooth, and beautiful curve every time? Not me. Clearly, y'all have seen my work. I can't do it. Okay? So that's why I'm being very particular about your x-axis. Good enough? Okay. Very good questions today, y'all.
Does it matter how far up the top curve goes?
Yep. Why? Good questions. You're answering your own questions. It means it's sinking in. Look at this one, guys. This is the one where things change a little bit. This was the example 1.6 from the other day. Okay, if you have it in your notes, but I don't really care if you do or not because we're doing it again anyway. All right, so here we go. Does it reflect? Yes or no? Yes. That means sine curve goes which way, Q? Down. Very good. Okay. Next thing, amplitude. My amplitude is the absolute value of -2, which is 2. That means it's 2 units above and below the oscillation line. Period. 2 pi divided by who? 2. Which 2 are we pulling this from? The one in front of x. Very good. Okay. 2 pi divided by 2 simplifies to what? Pi. 2 pi is 1 revolution. We are dividing 1 revolution into how many pieces? That's why it's 2 pi divided by v. Okay?
Why is it 2? Why is -2 2?
It's the absolute value. Absolute value of -2, which is 2. Okay? Here we go. Next piece, vertical shift. At who? At 1. Do I have enough information to start graphing? Yes, here we go. All right, oscillation lines at 1. And I've got to go 2 above, so 2, 3, 0, -1. You guys buy that? Okay. You with me so far? Sine curve starts on the oscillation line. And is it going to go up or down first? Down first, because it's been reflected. So I'm going to start here at 1, and it's going to go down, up, down. See what I just did? Now, I didn't mean to do that on purpose, but look at what I did. I messed up. So this is how I adapt. What's left to do? I got to put in my increments, which from the period on my x-axis. The period this time, though, is different. It's what? Pi. My halfway point, which is where my curve crosses the x-axis, is at what? Pi over 2. What's my quarter point? What's half of a half? Pi over 4. Very good. All right, now, to get my 3/4 point, check it out. 1/4, 2/4, 3/4, 4/4. Yep, it's all going to work out. Look at it. Study. Question. Here we go, Mr. Easter. If there was a 3, you're exactly right. It would be messed up, right? I am totally making this up off the top of my head. You know what that's going to mean, right? It's going to be messed up. But you can thank Mr. Easter. Here we go. Don't bully. Here we go. Stop whining. Here we go. Y'all are the only class that's got this problem. Thank you, Mr. Easter. Oh, and it's what curve? Ooh! Oh, it's cosine too. Oh, it's even worse. Is it going to reflect, yes or no? No. Is it up cup, down cup? Up cup. You do too, no. Shut your face. It is. This is difficult. Amplitude. What's the amplitude, y'all? Come on. 2. Absolute value of 2, which is 2. That means 2 up, 2 down from the Oscillation line. Here we go. Next one. Period. 2 pi divided by who? Oh. Oh. What? Dun, dun, dun. We cannot reduce it. We can't do crap. What the crap? We just going to let it hang out there for a second. Let's go and take care of the vertical shift at who? Oh, Lord. All right. Oh, Lord. Here we go. Oh, mercy. Okay, let's take a deep breath. Oscillation line is where? At -2. So let's put that on there first. My amplitude is 2, so that means it can go no higher than 0, no lower than -4. And it's a cup. All right, now, let's go on and draw it in there first. So it's an up cup. It starts at 0 and ends at 0, or the x-axis. And it's going to, minimum value will be at 4. Folks, I only put these dots up there for guides. I use them as guides. Here we go. Smooth and beautiful. Oh, Lord, have mercy. That is so smooth and beautiful. Here we go. Gorgeous. Gorgeous. Now, thank you, Mr. Easter. 1 period is what? 2 pi over 3. He's like, bring it. How am I going to figure out what the halfway point is? Fraction multiplication. I just signed that fraction multiplication. Thank you. So, here we go. That was not nice. Here we go. 1/2 of what? 2/3, which is 2/6, which reduces to 1/3. Well, that one's easy, right? Now we got to find halfway 2 pi over 3. So we're going to take 1/2 of, there we go, which is pi over 6. All right, now check this out. All right, you with me? Check it out. Pi over 6, 1/6, 2/6, 3/6, which is really 1/2. And then 2/3. Say, what? Take your calculator, if you don't believe me, and start at 0. Calculator, who's back there? Somebody go cut my calculator on for me. Let's look at this. No. The screen is so messed up, it doesn't make any sense when you graph it on a calculator. It won't. I don't think in the long run it will help you at all. You can, but I don't even check it that way. All right, here we go. Take 0 plus who? 1/6. Math frac. We get 1/6, right? 1/6 plus how much? What's my increment? 1/6. Math frac. Okay, I got 1/3. All right, I'm on the right track. 1/3 plus who? 1/6. 1/2. Is that what I got? Yes. Do you see what I'm doing, y'all? Isn't this exciting? I know, but do you understand how you can double check and make sure your fractions are correct? Okay? Thank you, Zach. Everybody say thank you, Mr. Easter. Thank you, Mr. Easter. I'm glad you did that. Hey, here's another one. And then I'm going to shut my face. Promise. And you know what, folks? If you do this homework, excuse me, if you do this homework, great. If you don't, whatever. Don't do it. It's up to you. I don't have time to hold your hand on this. Go if you need to go. Whatever. Who had, somebody else had pictures. You go when you need to go. Whenever it is. I don't, whatever. I don't know. I guess it is. I said it to the right time. But I've got 11:40:37. I got 11:37 on my watch. What do you guys have on your cell phones? Because I'm sure they're all off. It isn't. No, don't go for your butt. Yes. Y'all go on. Go when you need to go. I'm going to do this, and your homework assignment will be on the homework page. You're responsible for it. Okay? All right, here we go. It's 43 problems. I love you. I don't know how many it is. It is with like two more problems. Some of you I know did not do it at all because you were like, what the crap? If you didn't do it, you do it. If you did do it, you only have 2 problems. Does this problem reflect? Yes. Which way does it go? Up or down? Down. Amplitude. -2, which is 2. Period. 2 pi over who? Ooh, yuck. Ooh, yuck. Old school. 2 pi divided by 1/2 is 2 pi over 1 times 2 over 1, because y'all know I don't trust nothing but my old school. Which is, Q, you were right, 4 pi. 4 pi. Vertical shift at what? At x-axis. At 0. Well, 0, just know that it's at, yes. It's okay. 4 pi. Because we are dividing by a fraction. So it's going to be greater. Here we go. Oscillation line is the x-axis. Oh, label. 1, 2, -1, -2. Y'all cool with that so far? Yeah? This sine curve goes down first. So it's going to go down to -2, back up and down. And my x-axis is going to be labeled how? This one's difficult. This is going to take you some time. 0 to 4 pi. What's the halfway point? How did you figure that out? Half of 4 is 2. Half of 2 is 1. 1, 2, 3. 3. 1, 2, 3, 4 pi. Right on? Cool with this? Facile? So far? Good. We're going to cover phase shift tomorrow. All right, now listen to me. Listen, some people I know did not do this last week because you were like, no, I don't know how to do this, forget it. You're responsible for it tonight. There are 2 extra problems. And don't come up in here going, I don't understand. Think. No more spoon feeding. It's bad. Spoon feeding.